To truly understand business analytics, we need to ask the question of why now? As you will see in this course, many of the analytics techniques have been around for decades, if not centuries. Why are organizations suddenly realizing the importance of business analytics now? Well, besides the advancement in information technology that makes data storage and processing inexpensive and efficient, business analytics is made possible by the data deluge we witness today. The data deluge is the result of the prevalence of automatic data collection, electronic instrumentation, and online transactional processing, or OLAP. Next time you go to a bank, eat at a restaurant, trade a stock, or shop online, pay attention to how many data points are being collected during the process. There is a growing recognition of the untapped value in these databases. This recognition is driving the development of business analytics today. As data becomes cheaper and more plentiful, companies will begin to leverage the information in ways that were previously impossible or unfeasible. Ignoring the opportunity to implement business analytics will likely result in loss of competitiveness for companies. However, an inherent problem with data deluge is that clean, ready-to-use data is rarely, if ever, available in raw form. There is undoubtedly something useful in there, but it is not easy to reach. Therefore, business analytics can be thought of as 80% data preparation and 20% analysis. The tools for good analytics include information technology, data warehousing, data management, and statistical components that can be integrated to produce actionable knowledge. The consequences of data deluge are: every problem will generate data eventually, every company will need analytics eventually, and everyone will need analytics eventually. Organizations and individuals should embrace the opportunities afforded by data deluge. Organizations should define the data collection protocol in advance to maximize their opportunity for obtaining data that can yield useful information. Making intelligent use of data in a proactive way places companies and analysts in a unique position to improve efficiency, better understand customers, and stride ahead of the competition. For personal and professional development, business analytics offers business and IT professionals unique opportunities to advance their careers. As we have witnessed in the last decades, routine and less mission-critical work is being increasingly automated and shipped to low-cost regions. Business analytics is a skill set that is in extreme shortage today, and organizations view business analytics as a mission-critical area that helps shape business strategies today and in the future. Regardless of one's functional area, professionals with business analytics skills are likely to enjoy tremendous opportunities for career advancement and job security. Evidences in the business world have shown that proactively analytical companies tend to outpace competition. Unfortunately, not every organization has realized the strategic importance of business analytics or has the capability to perform business analytics successfully. In his book, Competing with Analytics, Thomas Davenport describes a scenario in which a grocery store collected massive amount of data from a point-of-sale card, only to sell the data to a third party, who massaged the data and sold it back to the company at a higher price. And at the same time, the company also sells the same information to the grocery store's competitors. This situation is called data stalemate. If the company chooses to develop in-house analytical expertise, the company would be able to save time and money and make more streamlined and innovative decisions. This example shows the importance of developing an analytics mindset or analytics culture in the company today. What does it mean to have an analytics mindset or culture? Well, let me ask you a question that may seem irrelevant to what we are talking about. How many piano tuners are there in Chicago? This is the question that Nobel Prize-winning physicist Enrico Fermi would ask his PhD students on the first day of class. Guess what the most common answer he would get from his PhD students? How can I possibly know? Well, that's what most people would think when you ask them a random question like this. Is that your answer too? Enrico Fermi would then perform his famous Fermi decomposition. If you look at this slide, it shows the Fermi decomposition in detail. Let's say there are approximately 3 million people in Chicago. Let's assume that, on average, each household has 3 people. Then there are 3 million divided by 3 or 1 million households in Chicago. Now consider the people you know. What percentage of households have a piano? Is 10% a pretty good guess? That means there are 100,000 pianos that need to be tuned in Chicago. If you ask anyone who knows piano, the person would tell you that it is recommended that a piano be tuned once each year, but many people don't play enough to do that. So let's assume that on average, pianos are being tuned once every 1.5 years, and that would give 66,667 tunings needed each year in Chicago. Let's assume that it takes a piano tuner 4 hours, including travel time, to tune a piano. If the piano tuner works 200 days each year, 8 hours a day, that would allow the piano tuner to tune 400 pianos each year. Let's assume the market is efficient, meaning that the number of piano tuners just meet the piano tuning needs of Chicago. Then it means that there should be 161 piano tuners in Chicago. After this series of assumptions and computations, Fermi would open a Chicago phone book and ask his students to count the number of piano tuners in Chicago listed in the phone book. They will find that the actual number of piano tuners is surprisingly close to the number estimated by Fermi. So what does this have to do with analytics or analytics mindset? Well, Fermi was trying to redefine what analytics or measurement is. Analytics or measurement is a quantitatively expressed reduction of uncertainty. What Fermi did with his decomposition is to reduce uncertainty, not trying to reach the exact number, but his estimate is a lot closer to the actual number than the common answer, which is, how can I possibly know? Given the new definition, now everything becomes measurable or analyzable. Having an analytics mindset or culture is not throwing up 2 hands and say, how can I possibly know? But trying to get closer to the answer by using a little common sense and imagination, as Fermi did. And analytics does not have to always involve complex machine learning or massive data. As long as you are reducing uncertainty, you are doing analytics. So anything can be analyzed or measured, really. As the organizations realize the importance and benefits of business analytics, the analytical landscape of the organizations will evolve. Historically, analytics have typically been handled in the back office and serve the basic needs to understand what has happened in the business to get where we are today. Over time, the power of analytical models has grown to where they are much more integral to organizational dynamics. Forecasting, predictive models, and advanced modeling are emerging as key operational components. Organizations are beginning to embrace the value of analytics and to appreciate how analytics can drive a business to be more efficient and more effective. Modern analytics have been moved to the front office and onto the desks of executive-level corporate officers. Analytics now have a direct impact on company performance, driving new behaviors from customers, suppliers, and others that will have an impact on revenues and costs of the organization. There are tangible monetary benefits that management can associate with analytical projects. The success of these projects breeds the desire for more models. The number and the usage of models will proliferate in organizations. As the result, business analytics will lead to faster and more accurate decisions, more empowered employees, and more satisfied customers and stakeholders. You may be thinking, isn't business analytics the same as data analysis we learned in business statistics class? Well, not quite. To answer this question, we need to talk about data mining, a key process in business analytics. Data mining is defined as advanced methods for exploring and modeling relationships in large amount of data. While exploring and modeling relationships in data has a much longer history than the term data mining differs from traditional data analysis in data, users and sponsors, and the methodology. The data used in data mining are usually massive, operational, and opportunistic. In traditional data analysis, data sets are often relatively small. They may contain a few hundred records. Data mining takes advantage of massive data sets that often contain tens of thousands or even millions of records. Because of the availability of computational power today, a large data set is no longer a handicap to analysts. Instead, it has become an advantage. Data mining makes the most sense where large volumes of data are available. Massive data sets help business identify meaningful relationships, patterns, and trends that would otherwise be hidden. And the large data sets also help analysts validate the outcomes of data mining from a more practical perspective. In traditional data analysis is often done by statisticians. Data mining is designed to be used by business decision makers. Who can be a data miner today? Any business or IT professional who has a basic familiarity with quantitative methods. While understanding the data mining techniques is critical, understanding where and how they are useful in business situations is more important. Being able to frame the business problems correctly and interpret the findings of data mining are also critical. Modern software applications and data visualization tools have made it possible for business and IT professionals to work with data mining tools with relative ease. And courses like this one would provide you with the understanding you need to perform business analytics with confidence. The methodology used in data mining is computationally intensive due to the massive amount of data and the sophisticated analytical techniques involved. It is especially designed to help organizations answer questions that are ad hoc or cannot be predicted in advance. While the traditional data analysis methodology focuses on explaining a given phenomenon, data mining methodology focuses on predicting the future events or actions. Therefore, data mining often offers organizations more practical applications than traditional data analysis does.